Alright, in example 4 we're asked to find f of g of x and its domain when f of x is x over x plus 5 and g of x is 6 over x. So let me just write down that f of g of x is, alright, that's f of 6 over x. And now remember f is x over x plus 5. So wherever there was an x in f, maybe I should do this in blue, wherever there was an x in f, I put parentheses, and wherever there are parentheses here I'm putting in 6 over x, because that's g of x, that's the output of g. Okay, so f of g of x is 6 over x over 6 over x plus 5. And now we could simplify this a little bit, because if we want to get rid of that that fraction in the denominator, so what we can do is we can multiply by x over x, and what that does for us is it makes this 6 over 6 plus 5x. So I'm distributing this x in here, and the x over x is 1, so you get 6 over 6 plus 5x. And now we're asked to also find the domain, so let me just write down that my final answer, f of g of x, is 6 over 6 plus 5x. And now to find its domain, we need to set the denominator equal to 0 and solve. So 6 plus 5x cannot be equal to 0, so that means that 5x cannot be equal to negative 6, so x cannot be negative 6/5. And so our domain, and we're not done, because for g of x to have an answer, or for g of x to have an output, x cannot equal 0. So up here we should also note that x cannot be equal to 0, otherwise g of x would not have an output. So our domain is everywhere where x does not equal negative 6/5, and we also need that x cannot be equal to 0, because otherwise g of x would not have had an output, so we wouldn't have been able to evaluate f at g of x. Okay, so our domain then is negative infinity to negative 6/5 union negative 6/5 to 0 union 0 to infinity. So that's the domain of f of g of x. So in general, to define the domain, you need to do a two-step process. You need to determine the domain of g of x, and then you determine the domain of the composition f of g of x. And then the domain is going to be the intersection of those two.